Alright, so this is question number 5 of November 18, paper 2. Now, we're given the diagram. I'm gonna skip part A because I think it's relatively easy and you should be able to solve it yourself. Now, in part B, we're told that a low pressure hydrogen discharge lamp contains a small amount of deuterium gas in addition to the hydrogen gas. The deuterium spectrum contains a red line with a wavelength very close to that of the hydrogen red line. The wavelengths for the principal lines in the visible spectra of deuterium and hydrogen are given in the table. Okay, so the light illuminates. Okay, so this is diffraction grating. The deuterium and hydrogen red lines can be resolved, and in the second order spectrum of the diffraction grating, show that the grating space of the diffraction grating is 2 times. Okay, so as you can see, I already solved this here. So I used the lambda over delta lambda equal to nm, and I took the mean values for, I guess you can use either the red line or the violet line. I used the red line. I took the mean values for lambda and then took the difference and found n. Now n is the number of lines in the diffraction grating, if I'm not mistaken. Now you want to find the grating space of the diffraction grating. So you do 3.5 times 10 to the power negative 3 meters over your total number of lines. So that'll give you the answer. Now part B is what's really interesting. So calculate the angle between the first order line of the red light in the hydrogen spectrum and the second order line of the violet light in the hydrogen spectrum. So for these type of questions, I would recommend you try to visualize it in your mind. But if you can't visualize it in your mind, then try to at least do a quick sketch. So imagine this is your screen, right? Interference screen, and then right here is where you have that principal maximum. Let's say this is your first order. Let's say this is the first order of the red line. I draw that in red, of that red light in the hydrogen spectrum. And this is your, give me a second. This is your second order. I probably should have started from here. Nevertheless, so that's your second order. I'm gonna delete this first order and write from here. Let's say this is your, okay, so this is your first and this is your second order. I think, if I'm not mistaken, that shit. See, this is the effects of studying for too long. Your brain just stops braining. Okay, let me quickly fix this. So this is, so this is second order and this is first order. There we go. All right, no complaining. Okay, so this right here is the angle of the principal maximum with the second order, and the angle alpha is the angle between the first order and the principal maximum. So we want to find the difference, the angle between the first order and the second order. So basically we want to find this angle right here. I'm gonna call that delta theta. All right, so obviously you should first find theta and then alpha and then find their difference. So if you look at your data booklet in topic 9 or topic 4, I believe, you can use this n lambda is equal to the sine of theta. So we know, okay, so let's solve for the second order now. So sine of theta, or let me write it as theta. So theta is equal to sine inverse of n lambda over d. Now if you calculate for theta, which is the angle of your second order, it's going to be, let's see, 2 times purple, right? Violet line, hydrogen spectrum, so 410, 180 over distance, which we found earlier. Yeah, so 2 times 10 to the power of -6. Shoot, why is it giving me an error? It appears I have made a rather slight mistake. Oh, okay, I saw. So this is, your lambda is times 10 to the power of -9. Okay. So this is going to be 24.2 degrees, 24.2 degrees, and your alpha, using the same formula, but instead of 2, you're gonna write 1 for your n, and lambda is red line, right? So 656.288 times 10 to the power of -9 over 2 times 10 to the power of -6. It's gonna give you 19.2 degrees. So if you find they're different, 24.2 minus 19.25. Was it 5 or was it 6? So Revision Village got 6 degrees, but I reckon there's probably like a range in the marking. So let me quickly check if 5 degrees is indeed correct or not. I have it on my iPad as well. Let's see. Okay, this one is faster. Okay, this is November 2018. November 2018. Physics paper 2, right? Yeah. Oh, marking. We need the marking. Okay. This is question number 5. Yeah, 5 to 6 degrees. Let's go. So 5 degrees is indeed correct. Good job, guys. Good job.